So the idea with BYOC is pretty simple, right? Instead of running all of the infrastructure in the vendor's cloud account and exposing a secure endpoint to customers, with the BYOC model, the vendor deploys and remotely manages all of the infrastructure in the customer's account. This approach has a number of benefits, but the big one that people usually really care about is something called data sovereignty, right? All the data stays in the customer's account, none of it ever leaves their environment, and this can be really valuable to some customers and workloads that really need it. But of course, like everything, the BYOC deployment model comes with trade-offs as well. And with BYOC, the big one is actually around security. And it's kind of a weird thing to say, right? Like the whole point of this was data sovereignty, keep all of the data in the customer's environment, none of it leaving. So why are we making trade-offs around security? Well, the thing you have to keep in mind is that most of the technology that ends up being deployed with this BYOC architecture, it's usually really complex technology, right? It's stateful things like databases and streaming technologies like Kafka, things with lots of nodes, local disks, state, replication, consensus, just a lot of moving parts where things can go wrong. And the fact that this technology is complex is why usually the customer is engaging a vendor to help them manage it in the first place. And so since this technology is so complex and stateful, in practice what it means is the customer ends up having to provide the vendor with sweeping privileges, give them access to their account, allow them to jump in, deploy things, upgrade things, give them access, and kind of in the worst case scenario, if something goes really wrong, the vendor and their support staff will have access to kind of get on SSH in, get on the boxes and fix things. And so kind of behind me you can see like a very small sample of the sometimes hundreds of permissions that a customer would have to give a vendor in the traditional BYOC model. And so this works, but it's a little bit risky from a security and liability perspective for the customer. And so when we were building WarpStream, one of the things we spent a lot of time thinking about was, was there a better way to do BYOC? Could we address some of these security problems while still keeping some of the benefits? And the thing that we realized is that we could avoid a lot of the problems with the traditional BYOC model by re-architecting the underlying system in a different way. And so we kind of looked at everything from first principles, and the question we kept asking ourselves was, what would a modern data streaming platform look like if it was built today, not only be cloud native, but also BYOC native? And to do that, we had to solve a number of problems, right? The first one we just had to address was the security problem. When we were building it, we really didn't want to have any access to the customer's environment. We didn't want to have any cross-account permissions. We didn't want to do VPC peering. We didn't want us or any of our support staff to have the ability to get into their environment or their machines under any circumstances. We just wanted to avoid all that. And if we were going to do that, then the software that was deployed into the customer's account had to be really simple, right? If we don't have the ability to kind of jump in and manage it remotely, it had to be really, really easy to operate. And ideally, it would just be completely stateless, just kind of the easiest thing you can kind of imagine running in the cloud. And we had to solve both of those problems while still maintaining the benefits of the traditional BYOC approach around data sovereignty and keeping all of the data processing and storage in the customer's account with none of the data leaving. And so that's what we built with WarpStream. WarpStream has what we like to call a zero-disk architecture. And so you can look at the entire WarpStream stack, and there's no local disks, there's no write caching, there's no EBS volumes, nothing. And what we do instead is we use commodity object storage as the primary and only storage in the system. And what that does is it increases the latency of the system a little bit, but in exchange we get a dramatically simpler architecture and a system that is much, much more easier to operate. And so if we dig a little bit deeper into WarpStream's architecture, there's two primary components. There's the WarpStream agents and there's the control plane. The agents are basically, you can think of them as like stateless Kafka brokers. They're thick proxies that sit in front of the object store. They handle batching, caching, and exposing the actual raw Kafka TCP protocol to the customer's applications. The control plane runs in our cloud account, and it handles a lot of the trickier distributed systems problems around metadata and consensus. It implements things like transactions and consumer groups and kind of all the things that make Kafka Kafka. And so with the agents running in the customer's cloud account and the control plane running in ours, the only infrastructure that is in the customer's account are these stateless agents that are super easy to manage, right? They have no topic partition leaders, no local disks. You can just add and remove containers, and that's how you scale the cluster up and down. You never have to rebalance partitions. If you accidentally delete all of them, you won't lose any data. Just like really easy to manage stuff. And so this hard split we've created between the WarpStream agents and the control plane kind of addresses the security problem with the traditional BYOC approach, right? We don't need access to the customer's environment because there are no stateful components to manage there in the first place. Of course, someone still has to be responsible for every component of the system, right? And so similar to the cloud providers, we use the shared responsibility model. And so the storage layer is owned by the cloud provider, right? When you deploy a WarpStream cluster, you create an S3 bucket, and the AWS S3 team is responsible for making sure that your data is durable, it's replicated, and that your bucket's always available. On the other side of the spectrum, the metadata and consensus layer is handled by us, right? We make sure that your metadata is always durable, that your control plane is always available, and that we scale the control plane with the throughput of your cluster. And so the third and final piece is the part that the customer is actually responsible for, which is managing these stateless agents in their own infrastructure. And like I said before, the agents are super easy to manage, right? You basically just apply our Helm chart, a bunch of stateless containers appear in your Kubernetes cluster, a CPU autoscaler is automatically configured, and you basically never think about them again. And so this addresses kind of the security problem I was talking about earlier, but we still maintain all of the benefits in terms of data sovereignty, because all the data is processed on the agents running on the customer's VMs, in the customer's network, and storing data in the customer's object storage bucket that we don't have any access to. And so this is all the security stuff is really cool, but there's actually a lot more to WarpStream than just improved security. And so the other thing I want to talk about is how WarpStream is actually cheaper to run than self-hosting Apache Kafka yourself. And the reason for that is, like Confluent Cloud Freight clusters, WarpStream was designed for the biggest workloads on the planet. Things like observability, logging, IoT, feeding data lakes. Use cases where there's a little bit more tolerance for higher latency, but the volumes of data being processed are really huge, right? And since WarpStream was designed for these massive scale workloads, cloud economics is really top of mind for us when we were architecting the system, and you can kind of see it everywhere in the design. So there are three ways that WarpStream will kind of reduces cost compared to running Kafka yourself. The first one is around networking. So if you run kind of like a really high scale, high volume Kafka cluster in the cloud, one of the biggest drivers of cost is actually just the cost of manually replicating data between availability zones, right? And with WarpStream, what we do is we use the object storage layer not only as the storage layer, but also as the network layer. And so that allows us to eliminate these fees entirely. The second thing that tends to make Kafka really expensive to run in the cloud is that disks in the cloud are just really expensive. Once you factor in things like replication and making sure that you have enough headroom for growth, the cost of storing a gigabyte of data on a local EBS volume in the cloud after replication is about 25 times more expensive than storing the equivalent amount of data in object storage. And so since WarpStream uses object storage as the primary and only storage in the system, your data is always stored in the cheapest storage medium available in the cloud. And the third way in which WarpStream can dramatically reduce costs compared to running Kafka yourself is around autoscaling. I'm sure a lot of people in this room are self-hosting their own Kafka clusters, and you'll know it's just really hard to autoscale a Kafka cluster and to do it quickly, right? Brokers have to be added, partitions have to be rebalanced, a lot of data has to be copied around, your cluster is going to be a little busier while these operations are happening, it's going to consume more resources. Since the WarpStream agents are completely stateless and all of the storage is offloaded to the object store, they're actually trivial to autoscale, right? You just monitor the CPU. When it gets high, autoscaler adds more containers. When it gets low, you remove containers. No partition rebalancing, no data copying around. And so by default, every WarpStream cluster has autoscaling enabled. And so your WarpStream cluster is always basically perfectly right-sized for the amount of throughput that it's serving right now in the current moment, and not how much throughput you might need to serve sometime in the next few weeks. And so all of these things, zero disks, zero zone networking fees, zero ops autoscaling, and zero access BYOC are why, despite WarpStream being a relatively new product, we've been able to attract a great set of customers that are driving really large workloads through WarpStream. Customers like Grafana Labs, Character.ai, Zomato, PostHog, and GoldSky.